Hello everyone, welcome to video lecture on software architecture and design pattern. Today we are going to discuss third module, design pattern catalog. So the next template sections is participant. So we had discussed about in the previous videos. So target, which is shape, defines the domain specific interface that client uses, and drawing editor, that is called as client. Collaborate with the object conforming to the target interfaces. Adaptee, that is EE. Text V defines an existing interface that needs adapting. Adapter, that is the text shape. Adapt the interface of adaptee to the target interfaces. So now we will move on to the next template sections. Collaborations. Here, client call operations on an adapter instance. In turn, the adapter calls adaptee operations that carry out the request. So collaborations, we can say it is an instance of adapter whenever the client call an operations based upon the adaptee will be carry out the request from the adapter instance. So that is the collaboration. So now the next template sections in adapter structural design pattern is class and object adapter have the same different, or we can say trade-offs. So this is the consequences, we can say that. So there are the class and object adapter have the particularly trade-off of class adapter. So we have there are certain things in case of class adapter. So what it does, adapt the adaptee to target for committing to a concrete adapter class. As a consequences, a class adapter will not work when we want to adapt a class and all its subclasses. This is the situations a class adapter can how it is going to work it. Let us adapter actually override the sum of adaptive behavior of the particular classes. Adapter should subclass of the adaptive what is that adaptive classes. Similarly, which introduce only one object and no additional pointer indirection is actually not needed to get the particular adaptee, because client adapter will be call the adaptee at an instance. So adaptee can request or fulfill the whatever the call by adapter. So in case of next, we will think about an object adapter. So we will see in the next slide. So an object adapter. So if you consider that one, what is that one? Or an object adapter consequences. Let's a single adapter work with many adaptees. Actually, this is meaning that the adaptee itself and all of its subclasses. So if any, the adapter can also add functionality to all adaptees at once. So that will be taken into the a particular an object adapter. Similarly, another point to that an object adapter is makes an object adapter which makes it harder to override adaptive behavior in case of. So what it does, it will require subclassing adaptee and which will making adapter refer to the subclasses rather than the adaptee itself. So that is the one point in the consequences and object adapter. If we consider as a consequences of an object adapter, these 2 points will be consider. So here, in other than that, there are lot of issues will be there. There are other issues to consider in using adaptive pattern. How much adapting does adapter do? So this is the consider the case of adapters vary in amount of actually work they what do adapt to the target interfaces. In the, for example, we have the changing the name of the operations. For example, supporting an entirely different set of operations. The amount of work adapter does depend on how the similar the target interface is to the adaptee. So the next issue, other issue will be considered in the next pluggable adapters. So that is the class more reusable when we minimize the assumption other classes must take usage. So this is the considerable pluggable adapter to describe the classes with a built-in interface, that is the adaptation. Similarly, one more is using two-way adapter to provide the transparency. So in that case, potential problems, a two-way adapter can provide such a transparency, how specifically reuseful when two different clients need to view an object in the different way. So like that is the constant variable, for example, the state variable and the constraint state variable. In that case, so we need to consider. So the next is implementation section. We know that although the implementation of adapter usually here we are some issues we should keep in mind. So while implementing this adapter structural design pattern, there are certain issues will be there. We need to keep it in mind before implementation. So now we will take what and all implementation issues. So very beginning with one is the major issues implementing a class adapter in C++. Actually implementation of a class adapter. So usually inherited publicly from target. We have the main class is the target and privately from the adaptee. That is the text and the text shape which we had in the motivational example. Thus the actually adapter would be subtype of target but not of the adaptee. Another issue will be we should consider in that one pluggable adapter. Let's look, there are way to implement pluggable adapter is the tree display which can lay out the and display the hierarchical structure automatically. So what are the ways we should take it that one pluggable adapter can be implemented, and we should consider the what are the issues. That is the there are two approaches we can say, that is the narrow interface leads to the three implementation approach. There are three implementation approach will be taking into the consider. The first step which common to all the three of the implementation discussed here to find narrow interface for adaptive. So that is the majorly we consider narrow interface which leads to the there are three implementation approaches which comes in the what is the issues will be considered in the implementation part. So we will discuss this. This is the actually tree display, or what is that one. So using abstract options, so that is the narrow display will be taken here, tree display of client comma target. So okay, get children by node here, create graphic node of node display and build tree node. Okay, so this is the an example case of the what is the narrow interface, how we are going to pluggable adapter. So these two are the again pluggable adapter. Directory tree display, get child of node, again this one file system entity, that is the adaptee. So this get children small code will be written add public child. How this tree display majorly client comma target to the to pluggable adapter. This is the pluggable adapter directory, how it is can call and how it can be pluggable to the particular adapter. Okay. So here which continue, there are three implementation approach we will discuss one by one here. The first one is so using abstract operations. So here there are three issue of implementation defined corresponding abstract operations for the narrow adaptive interface. So in the tree display classes. So here, so what it does, actually subclasses must implement abstract operations that we need to consider here. Another point, adopt a hierarchically structured object. So I'm giving an example. For example, directory tree display we had seen in the previous diagram. Subclass will implement the operations by accessing the directory. So directory structure that we had seen in the directory structure. What is that one? Directory tree display of get children create a graphic node. So that we had a directory structure. Actually, tree directory display which always specialize the narrow interface so that it can directory structure made up of file system entity object. We had seen in the directory tree structure to the file system entity, in bracket that we had seen adaptee. So that is the using an abstract operation. So next one is again narrow interface implementation consider in the using an delegate object. So with consideration this, in this approach, tree display forward the request for accessing a hierarchy structure to a delegate object. So what it does, actually tree display can use a different adoption strategy by substituting the a different delegate. So one example here, suppose there exists a directory browser. Okay, the users of tree display directory browser might make a good delegate for adapting tree display to the hierarchical directory structure, so that we can take dynamically in the language like small talk or objective programming language or objective C. This approach is only require the interface of registering the particularly delegate with the adapter, so that we are going to consider, and tree display simply actually simply forward the request to the delegate. So which uses this approach heavily to reducing the what it does using delegate object, we will reduce the subclassing, more number of subclassing can be reduced. So this is the another narrow interface implementation issues will be consider. Next one more is third implementation approach in the narrow interface, that is the parameterized adapters. Okay, let us discuss what is the parameterized adapters. There is actually way to, this is the usual way to support pluggable adapter in a small talk to parameterize in an adapter with more than one block. So this is the specifically if there is a more than one block in the tree blocks or tree directory or command or browser or delegate. So whatever the more than one blocks will be there, the block constructor supports the adoption without the subclassing. This is the major point we need to take it, because block construct which supports always adoption without any subclassing, that we can see that that is the parameterized adapter. So here actually the code will be like this. For example, okay, tree display which stores one block for converting a node into the graphics node, and another block always accessing the node's children. So okay, one board is graphic node and other node is accessing the children. So if you want to write a segment of code is like the directory display equal to tree display on tree root get children block, that is the node get so directories create node block, again node create a graphics node. So this is the way building interface adoption into class. Actually this approach offers the convenient alternative to the subclasses. So which is the again this is the parameterized adapter is reducing the more number of subclasses. So after this implementation we are going to discuss the next one is sample code. So now this is the sample code. So we are not going to take the complete code this is, because sample code will be taken for the particular uh, design pattern. So here, so we will break this sketch the implementation of class and object adapter for the motivational example, beginning with the class shape and text view. So we are taking into the consideration of motivational example class shape. So then all the public shape of the function here, virtual wide bounding box, that is the point, and bottom left, point, bottom right, which are the constant. Virtual manipulator, that is create manipulator constant. Class text view, another segment of code. Public, which is the public, and text view with the method. Void get origin coordinate x and y, which will be the constant, and void get extents of coordinator width and height is the constant. Virtual is a boolean type, is empty, so we have taken. So actually here shape, assume that bounding box we have taken shape, class shape, which is defined by opposing the corners, which are the x and y coordinate or top or bottom corners will be count. Text view, actually text view which be defined by the origin height and width of the shape. Also defines the create manipulator operations for creating the manipulator of the object here. So we know how to animate the shape particular manipulate. Text view also has no particular equivalent operations. Here the class text shape is an adapter between these different interfaces. So this is a small segment of code will be taken. So no need to be taken for complete code. So the next template section is noun uses. The motivational example which comes from ET++ draw, a drawing application based on ET++, that is the ET plus as classes for text editing using an text shape adapter classes. So where exactly noun uses will be there. Uh, interactive abstract class user interface element, we elements such as like scroll bar button menus. We also define the graphical object class or a structured graphical object like line, circle, polygon, splines, both interactor. A graphic should have the particular parameters like that one, but they have the different interfaces and implementation. So this is a noun user which will be taken into a particular object adapter called graphics block or subclasses which contains graphic interface. Similarly, pluggable adapter are common in the object works like that small talk. This is a standard small talk which defines a value model class for views that display a single value. A model which defines a value or interface for accessing the particular values that will be taken. So another object works or small talk which always includes subclass of value model, for example pluggable adapter. So another example from the object works or small talk in the uh, table adapter class. The table adapter can adapt a sequence of object to the particular tabular presentation. In some classes in the net HT or AppKit, so that is add 94 use delegate object from to perform the interface adaptation. An example is the NX browser class which can that can display hierarchical list of data. So NX browser use the delegate object for accessing and adapting the particular data. So this is the noun users depending upon that one. So we need to take it into the consideration actually how it can be used in the particular adapter class or an adaptive. So next is the related pattern. So this is the last section of the template. Related pattern. Related pattern like the bridge has a structure similar to an object adapter. So here, so that is the bridge structural design pattern. which are similar to an object adapter, but bridge has a different intent, meaning intent is the purpose. Actually bridge purpose is different but almost related to this adapter structural design pattern. It means that what you mean by this separate an interface from an implementation so that they can be varied easily and independently different. So actually an adapter is meant to change the interface of an existing object. So bridge is the, so another way we need to take it into the particular consideration. So the next design pattern is bridge structural design pattern. The first one in the template sections, intent, that is the purpose. Actually the bridge design pattern which decouples an abstraction from its implementation so that the two can vary independently. So this is the actual the purpose, the aim of the bridge structural design pattern, also known as, this is, we can also call it as a handle or body, the complete body, because this is the bridge shape. So next is motivation. So actually when an abstraction can have one of several possible implementations, usual way to accommodate them is to the usually is to use is it as an inheritance. Actually an abstract class which defines in interface to the abstraction and concrete subclasses implement in the different way. But what will happen here? But this approach is not always flexible enough. So inheritance binds an implementation to the abstraction permanently, which makes it is difficult to modify, difficult to extend, and difficult to reuse the abstraction and implementation particularly independently. So with consideration, this implementation of portable window abstraction in a user interface toolkit. So this is the motivation example we have taken on a window abstraction in the user interface toolkit. Actually this abstraction should enable us right to write applications that work on both the, we have taken example of this one, X Windows system, and then IBM, that is a presentation manager window, that is PM window, for example, we have taken. So using inheritance here, in this case using inheritance, so we, what we do, so we could define an abstract class windows here and subclasses X window and program presentation manager PM windows. What it does, that implements this window interface, actually that implements the window interface for the different platforms. And how does this approach can work? But this approach we can say has a two great drawback. So one is it's inconvenient to extend abstraction here to cover different kind of windows or new platforms, that is window X window PM. So another part we have taken here, imagine that is the a window followed by X window, PM window, icon window. So this is followed by the X again icon window and PM icon window we have taken. So here window abstraction icons. Okay, to support icon windows for both the platform, we have to implement a new classes X icon window. Another one is PM icon window. So we will have to define two classes for every window. Supporting a third platform requires yet to another window subclasses for every kind of windows. So this is the approach we are now going to tell about this. Inconvenient to extend a window abstraction to the cover different kind of that's the new platforms. Yes, another one is it makes the client code platform dependent. whenever a client create a window, it's instantiate to a concrete class that has a particularly specific implementation, so that we need to count it. So that are the two different, so we are saying that different drawback of these approaches. So here only one thing is, uh, only window implementation should depend so on the particular platform on which the application, what type of applications what we run. Therefore the client code should instantiate windows without mentioning the particularly specific platforms. So that is the this thing. So how we can address these issues, that is the a suitable structural design pattern is bridge design pattern.